comes up, I want to make sure that there is a present on your presentation files, on your downloads, make sure that you have single versus dual task. It's a recording form, because we're going to be using that real soon here. So if you didn't print it out, make sure you pull it up now and then minimize it, because it's a Word document, so you'll be able to fill it in right there on your computer. So that's one thing that's really important. Make sure right now that you have like a watch handy, or with a second hand. You can also use your phone. So you're going to need like a stopwatch. So the first presentation is going to be my first study, and I want to tell you a little bit about this study. I was lucky to be part of a grant with Marjorie Woolacott, Dr. Marjorie Woolacott, who is the primary investigator. She got a grant from NIH, National Institute of Health, for about $5 million to study children with cerebral palsy. And I happened to be at the University of Oregon at the time, and I happened to have the right question in order to get on the grant. So the first study is a developmental study, and the second study is about cerebral palsy and attention. So with that, we're going to pull up a question. There was a question at the end, or near the end of the last session, regarding auditory stimulation or sound sense and postural control. So I'm just going to have Ben pull up some of the research that I just happened to look at for auditory and posture control, and it seems to be a fairly recent area of research right now. And what I've done here is just kind of copied for you some abstracts on sound and posture control. So it does seem like external sound influences body sway, and particularly in medial lateral, which is, remember, your side-to-side sway. And then the specifics of the question were really looking at sound used by people that are blind, individuals with a loss of vision. So I also included loss of other sensory systems like the vestibular system. So if you go through this, and you have that, you can download this and kind of see some of the findings. Like I said, the abstracts aren't always detailed, so you don't always get a methodology with that to really understand some of their discussions. But I think the most important thing is that people can use sound to stabilize postural control. So it may be a way of training children or adults that are congenitally blind to use sound as a way to stabilize their posture. So I just wanted to answer that question a little bit more clearly. Okay, so can everybody hear me? A show of hands. I see that there's some that can't hear me. Can everybody hear me? Okay. All right. Good. So, yeah, some can't. All right. All right. All right, I'm going to try and get a little closer. Does that help? Okay. Yes. Good. Okay. Thank you, Melody E. All right. So let's move on. And like I said, you have this list of abstracts, and I know there's some of these articles that are free download. So for those of you who are more interested in this, there is an article that has free download at PubMed, PUBMED Central. So the search terms I use were auditory, postural control, and blind. Okay, let's move on to the slide, the presentation now. Okay, let's look at the objectives. So in this, like I said, this is the meat of this whole three-part series. I really want you to gain an understanding of attentional requirements of postural control and how that changes throughout development, because in the third session, we're going to be looking at how to apply this kind of knowledge based on this understanding. The other one is gain an understanding of the attentional requirements of postural control in children with cerebral palsy. So we have a developmental perspective, and then we're going to look at children that have disabilities in both attention and postural control. And then we want to use this knowledge. We want to use this knowledge in assessing behaviors that we may observe in classrooms and school environment. So if attention is required in postural control for children, what is it that we may see in a school environment that has that many of the tasks are multitask components? So those are the objectives for today. So the question is posture control automatic, or does it require attentional resources? And by attentional resources, we mean conscious processing. So that is the question that was mainly posed when I went to the University of Oregon. What's going on with posture control and attention? So remember from last week, we looked at all the sensory systems, or not all the biological systems that really influenced posture control. You know, the alignment of the musculoskeletal, the 3 different systems, sensory systems, what strategy children used, what strategy children used to control their posture. We looked at the muscles that work when you sway from side to side, and the postural tone, how important that was. The central nervous system and how it uses a body schema, or like a roadmap of how the body works. So all of that is interactive, and all of that contributes to the system we call postural control. Now what we're going to look at is cognition, and specifically attention. Is attention needed to control posture? So let's move on, because we've talked about this. Okay, systems of attention. So again, let's look at attention. We're going to be concerned in this study with the executive function of attention. So remember, that has a goal of being more task-oriented, and it also controls many of these other lower attentional networks, like the orienting system and the arousal system. But the selective attention, or what children pay attention to, is also affected by language development, or sensory motor systems. You know, what kids are interested in is what they can do with an object. And also cognition and past experiences contribute to what children attend to. But right now we're going to be looking at the executive function of attention and concerned with that. So in that, let's review what we're talking about, the limited capacity theory, because that's going to be important when we talk about putting 2 tasks together. So for each individual, there is a finite attentional resource for processing information. So each of us have only a certain amount of, think of it as energy, for conscious processing. And so performing any task requiring attentional resources is given a portion of this capacity. Therefore, if two tasks are performed together and they require more than the capacity, the performance on either or both deteriorates. Practice of a task leads to reduction in the need for attentional resources. Now, this is going to be really important when we get into application. So, based on this theory of limited capacity, what researchers have done to test whether posture control requires attention is that they've put a postural control task, which they've called a primary task. They have the adults or children stand in a certain position, and then they have them perform a secondary task, which would be a cognitive task. So what they're saying is if that postural control system or postural control increases in instability, if that postural sway increases, then you have attentional requirement for that posture control. But you could also have a deterioration in the reaction time or accuracy of the cognitive task. So either one of those can deteriorate, and it would still indicate that attention is required for posture control. So they use this dual task paradigm to study this. So have your recording form ready, because we are going to have you guys do a dual task and a single versus dual task mini experiment for this, because I think it's important. In my last workshop, one of the evaluations was that they really liked the fact that they experienced the dual task condition, because it gave them a better understanding of what their children in classrooms are going through. So I think this is really important for you to have a experiential understanding of what we mean by attention and posture control. And so what I'm going to have you do is, let's right now pull up the recording form. So if you have your recording form handy, this is what you're going to be recording on. So let's look at it. So on the far left, okay, in the far left here, vertical column, you have the conditions of the task. So you have a single task and two dual tasks, okay? Across the top, you have the different kinds of stances. You have a wide stance, which is when you performed in your first session, it was just your normal stance. We call it wide stance. And you have a Romberg stance. Now I'm going to explain what the Romberg stance is. Okay, the Romberg stance is when you stand heel to toe. So you're standing with one foot in front of the other, with the heel of the forward foot touching the toe of the back foot. Okay, does everybody understand that? Just give me a little hands up. You understand Romberg stance? Okay, good. Okay, so what we're doing in the Romberg stance is we're really lessening the base of support. So it should be a much harder posture control task. So first we're going to do the baseline, and it's just the baseline is just for you to get an idea of your sway. Okay, so I'm going to give you a certain amount of time, and you're just going to get an idea of what your postural sway is like with just concentrating on your posture. So you're going to be standing like as still as possible with your arms crossed. And I will give you I will time you. I'll say go and then stop when we get there. And then you're going to perform. Remember the Stroop task that we did, the colored words? You're going to perform the easy version in the 2 stances, and then the more difficult version in the 2 stances. So what you're going to do, the arrows are a check mark. Did my sway increase in wide stance from the baseline? The same with the Romberg. So you're going to do the same in the more difficult task. Did my sway increase as I even did the more difficult task? And we're going to be asking you questions along the way after this recording form. We're just going to get an idea of hands of people that had interference and postural control. So that you're also going to time yourself on the Stroop task. So if you're working in groups, this whole process is going to be so much easier because you can pick a subject and somebody can time and then somebody can look at the sway. So it's going to be a little bit more difficult in the individuals to come up with some exactness of accuracy or reaction time. But I think the most important part that I really want you to glean from this is how you feel about it, is what's happening to your posture control and what is happening to your response time. Because this is when you're really going to start looking at the interference. It's going to really, I think, be a lot more clear when we get to this more difficult task of the Stroop task. Okay. So for those of you that had recorded your Stroop task from last week in the sitting position, see if you can find that information and write down the seconds with the test 1, which we're calling the easy Stroop task, and the difficult one. I think a lot of you came in at between 6 and 10 seconds on the easy task, and in the difficult, many of you were between 25 and 30 seconds. So let's have you go ahead and write your Stroop baseline right now. And if you tracked your accuracy, which should read errors, do the missed. How many did you miss? Okay, so are there any questions on that? Okay, looks like everybody's doing it. Very good. Okay. So keep this handy because you're going to record what you're experiencing. And let's go on to the next slide. Okay, we're going to start with just the posture only. So what I want you to do is now stand up. And I want you to stand with your feet in a comfortable distance apart like you usually stand, your arms folded in front of you. And I want you to really concentrate on keeping as still as possible. So when I say go, we're going to do this for about 20 seconds. I want you to concentrate during that 20-second period on keeping as still as possible. Okay, go. Okay, stop. So there's not too much to record, but I just wanted you to feel what sway you do have. Is it moving fast? Is it going way out to the toes or way back to the heels, or is it pretty much within the center and you're not swaying very fast at all? So go ahead and mark any of that. And I'll give you a few seconds here to mark that. Okay, let's have you stand in the Romberg position. And we're going to stand in that position for about 20 seconds. Okay, ready? Your arms should be crossed. You want to concentrate on standing as still as you can. All ready? And go. All right, and stop. Now, what I want you to record is how many took a, if you took a step, record that. If you noticed that you felt a little bit more unstable than just the regular wide stance, put that in. Because we're going to be asking some questions later on. So I want you to have kind of a record of your experience. Okay. Okay, we did the Wyatt and we did the Romberg. So, just from this, we have a question. Which stance position appeared to have the most instability or the more postural sway? So if you just want to say none, if you want to write wide stance or you want to write Romberg, just go ahead and write it in the question and answer. Yeah. Okay, good. Thank you for doing this because I can tell you guys are doing this and it really helps me get a feel for what you're experiencing. So good. Excellent. So Romberg, everybody Romberg. So good. So we do have one that's easy and one and a postural control challenge that's challenging. So that's very good. All right. Let's move on. Okay, so now we're going to go to the four conditions of the dual task condition. So this is where you really want to know what's going on in your posture sway, and you really want to know what's going on in your cognitive processing. Okay, so let's pull up the Stroop task. So Ben will need the Stroop task. There we go. Okay, so see if you can keep this handy on your computer. I don't want you holding it because again that complicates your posture control task. So you want to still stand with your hands crossed, and if you're doing it individually, see if you can hold your timer in one of your hands and or stopwatch and time yourself on the Stroop task. So you're going to stand in the wide stance, and this should be what you're going to do is just read the words. You're going to time yourself as fast as you can. You're going to do it as fast as you can and time yourself from beginning to the end. And you're going to also stand as still as possible while doing this. So let's have you just get into that position of wide stance. Cross your arms. And let's hold it for a little bit. And when I say go, you're going to begin the Stroop task. Stand as still as you can. All right, go. Okay. I imagine everybody's done by now. So look at your recording form. Look at the wide stance and the easy Stroop task. Did you do a lot? Did you increase in sway, or was sway pretty much felt like it was the same? Or did you really increase in postural sway with the easy task? So mark that. And mark if you had an increase in your reaction time from like your baseline. And we're going to call plus or minus 4 seconds as significant, because a lot of you had between 6 to 10 seconds. That was pretty much the range. So we're going to go plus or minus 4 as a significant increase, 4 seconds. So record that. Okay, we're going to keep test number 1 up. And now I'm going to have you get into the Romberg stance. You're going to perform the same test 1 in the Romberg stance. Arms are crossed. You're going to concentrate as much as possible on being as still as possible and also as fast as possible performing the Stroop task. So when you're ready, let's get into the Romberg, arms crossed. Concentrate right now on holding that position as still as possible. When I say go, you're going to start the Stroop task. Ready, go. Okay, and stop. Okay, so at the end of this little experiment, I will be asking questions. Some of you are already answering me, so that's good. But I'm going to be asking these questions specifically at the end of our little demonstration. So, but make sure you record. Did you have really an increase in the Stroop task in the Romberg? Did you have an increase or an interference in posture control in the Romberg with even just the simple Stroop task? So kind of write those down in your recording form. And I'll give you time. Note anything that went on with postural sway. Did you sway faster? Did you have some big, large sways? Did you step out of position? Did you feel it more in your ankle side to side, or did you go front to back when you swayed? So some of those things you can write down. Okay, now we're going to go to the second Stroop task. Test number 2, which is a little bit more difficult, and as we saw in session 1, a lot more attentionally demanding, because a lot of you had lot slower reaction times to complete it. Okay, so get your recording form out and find where it says dual task and posture and Stroop task difficult. All right, so we'll start with wide stance and get in position, arms crossed. Remember, you're going to concentrate on standing as still as possible. At the same time on this one, you're going to read the color of the ink, not the word, the color of the ink. Okay. Ready? And go. Okay, and stop. Now, write down any of your reaction times in your recording form. Let's say write down your reaction time in the wide stance for Stroop, or write the errors. Some of you may have missed one or two. Did you notice any increase in your wide stance sway from, let's say, baseline, where you're just posture only, just standing without a task? Note that down, whether it was backwards and forwards or side to side. Okay, now I want you to stand in your Romberg stance. Okay, so we're going to be in the Romberg, a little bit more challenging. Arms crossed. Remember, you're going to concentrate on your posture as well as going as fast as you can on the Stroop task. So you want to go as fast as you can on the Stroop and concentrate on being real still and standing. So arms crossed in the Romberg. Make sure you have your stopwatch ready in your hand. You want to record your time. Okay. Get ready. Again, read just the color of the ink. And go. So when you're done, record your responses, your reaction time, and anything about your posture. Some of you may have actually had to step out of the Romberg posture, or you really noticed a big increase in sway. And some of you may not have had that much of a change. So just note whatever you notice in this condition. And we're going to just really compare the conditions. And I'm going to be asking you questions. So look at your recording form as we ask these questions. Okay. Let's go ahead and pull up the presentation. Okay, so I'm going to be asking a question. I'm going to be looking at a show of hands. So the first question is, in single versus dual task, in other words, posture only versus posture and cognitive task, did the postural sway increase when performing the easy Stroop task? That should be test 1, not test 2, compared to standing without a task in the wide stance. So look at your wide stance, single versus dual task, doing the easy Stroop. So a show of hands that had a change in postural sway in wide stance when performing the easy task. Aha. Just a few. Okay, so most of you could stand, pretty much did not have a change in your postural sway when doing an easy Stroop task. And that would probably be understandable at this point, and we're going to go into that a little bit later. Okay, so what about the Romberg, the more difficult stance? Did you have a show of hands that had an increase in postural sway in the Romberg stance, doing the easy task? Few, okay. All right. So most of you are able to stand in the Romberg stance and do this easy Stroop task without having any postural interference. All right, let's go on to the wide stance versus Romberg. So most of you didn't have any interference in any of those stance positions. So using the easy Stroop task, we really can't say at this point which of those stance positions requires more attention, because most of you didn't feel a difference in any of those stance positions. Now, if we were measuring you in a laboratory on a force platform that can measure millimeters of movement, it may change. But just from looking at it or feeling it, if you're standing by if you're doing this by yourself, you probably would not detect a change. So, did a show of hands if the reaction time or accuracy changed with the performance of the easy Stroop task in wide stance? Nobody. So everybody pretty much had the same reaction time in the standing position that they did in the sitting position, which was your baseline, as you remember. Very good. Okay, so the next one. But when we added the Romberg, did anybody see a change in reaction time? Okay, show of hands, a few. Okay, a lot more saw in that than in the postural sway. Okay, but not very many. Most of you did not experience a reaction time increase in either of the stance positions, which means that either your attentional capacity is big enough to do it all, or these stance positions don't require a lot of attention. Or if they do require a lot of attention, the cognitive task isn't showing that. It's too easy. All right, so what happens in the more difficult Stroop task? Now I'm hoping that we're going to get some different answers. So let's look at single versus dual tasks. So in wide stance, so let's start. Did postural sway increase when performing the more difficult Stroop task compared to standing without a task, which is your baseline? So in the wide stance, and let's have a show of hands that noticed a little bit of sway difference in wide stance when doing that more difficult postural control or Stroop task. Okay, we've got a lot more answers here. We've got a lot more show of hands that noticed an increase of sway even in wide stance with the more difficult Stroop task. But the majority of you still pretty much did not notice a difference. So, which shows that wide stance probably doesn't take that much attention. And we know that the Stroop task is very attentionally demanding. So wide stance probably doesn't take up that much of attentional resources. But what happens when you did the Romberg stance? Did the Romberg stance become a lot more unstable when you did the difficult task? So let's have a show of hands that maybe noticed an increase in sway in Romberg doing the more difficult task. Okay, we're getting a lot more answers here. Yes, okay, good. All right. So this is what we would expect, is that we would expect, since the Romberg stance is not a stance that we often RN, that it would be a fairly novel task. And probably, and we know it's more unstable, so it would probably demand a lot more attention. Let's see what happens to the wide stance versus Romberg. So I want you to write in which stance position had the greater increase in sway from baseline to the dual task condition. In other words, when you compare wide stance in the dual task position to Romberg in the dual task, which of those had the greater interference in postural sway when you did this difficult task? Okay, so a lot of you are saying the Romberg. Some didn't notice any. Romberg. Many of you are saying Romberg. Which we would really expect that the Romberg would have the greatest increase in sway because of the instability. Very good. So let's look at the cognitive test. So maybe your postural control task, maybe you didn't notice anything in the postural control. Maybe you were able to keep the sway from increasing. But what happened to the cognitive tasks while you were doing that? So what I want you to do, look at your form. So did the reaction time or the accuracy, or we'll call error, change when performing the difficult Stroop task in the wide stance? Anybody experience an increase in your reaction time? No. Okay. So definitely wide stance really does, for adults, does not take a lot of attentional resources. So what about the Romberg stance? Did anybody experience reaction time increase in the Romberg stance? Okay. Wow, you guys were really on this cognitive task. So, okay, some of you did. Not very many of you guys experienced a cognitive task detriment, which we're going to see that seems to be the case. It seems that posture sometimes is sacrificed for the cognitive task, and just keep that in mind, because I think we are going to see that in the study that I did also. All right. So, did any of you experience interference in both compared to the baseline in the difficult task? Just a show of hands. Nope. Okay. When I did a workshop on this, I had people stand on foam. So I took away also a sensory system that they could use for balance. And we had a lot more problems in postural control interference the minute I changed the sensory environment in which they were to do this. So you ought to try that on your own. Get a pillow or something at some point after this workshop and see if standing on foam and taking away one of the sensory systems might change the difficulty of the task. Okay? All right. Some of you may have taken my workshop before and you're responding that it was difficult. So thank you for doing that. Okay. So single versus dual task. So based on your observations and the theory, remember the theory of limited capacity, which of the two stance positions required the most attentional resources? Just write down which stance position you think most likely required more attention. The Romberg, right, right. And which test of the Stroop test caused the most interference in postural control? One or two? Right, 2. Okay. So these are the questions we're going to see have also been answered in other research. But right now, let's just model what we just did, okay? So remember that in the global, we call it the executive function. The executive function is that circle. Let's say that's the conscious processing area is this circle. And in it, we have several circuits that do several things, that come in and work together to process some stimuli that needs a response. So you have allocation of attention, you have motor programs, motor circuits, you have memory circuits, you have perceptual circuits, including language, and you have circuits that compare and evaluate what's going on or the importance of the task. So motivation would be part of this whole conscious processing. And then on the outside of that, you have subsystems that can work pretty much independently. Now remember when we did it last session, we looked at that easy Stroop task and the word, saying the word, reading the word with the same color, how easy that was. And it didn't really require anything in this global workspace to be processed. So it pretty much could be automatic. And so our question is that's the same with posture. So if we look at posture sway, can we just sway, have the sensory input, and then automatically have the posture reaction in our muscles without having any of this going on? So that's really the question we're asking. Is that the case, or is this the case? Attention is needed. In other words, the sway is accessing for higher level processing, and attention needs to be allocated to different aspects of that postural sway to reduce the postural sway. So those are the questions we're asking. And where does that happen? Does it happen in wide stance? Or does it happen in Romberg stance? So let's look at wide stance. Now, a lot of you did not, if we added the secondary task, the Stroop task, which we saw from the first session was pretty easy. That test 1 was really a stimulus response. Not too many people needed attentional resources for that. So if we put that with the wide stance, most of you did very well. There was really no change in sway and no change in reaction time. So you did pretty well, but it really doesn't yet tell us about attention because this task, secondary task, is pretty easy. We know it doesn't require attentional resources. So as adults, even if we do require attention to stand wide, we still have plenty of attentional resources to do it without it affecting sway. But what happened when we added the Romberg test? So even with an easy Stroop task, many of you there's about 4 or 5 of you that had some experience and increase in the sway. But most of you, for the most part, had no change in sway. So it doesn't mean that you didn't have needed attention. It just means it could mean that you had plenty of attentional resources to just look at posture control for Romberg, which resulted in no change in sway. Your secondary task needed no attention, so it didn't deteriorate either. And that's basically what we got for most of you. So, but there was a few of you that had an increase in sway, even in the easy Stroop task. So with that, for some of you then, if you look at the two together, you could say, I didn't have it in the wide stance. I had no change in sway in wide stance, but I had it in the Romberg stance. So in this case, you can say that more attentional resources were required to control the Romberg stance compared to the wide stance. But like I said, not too many people had this condition. But when we added the more difficult Stroop task, we've got more people in wide stance. Some people had an increase in sway and some didn't. So again, in the wide stance, some people had an increase in sway. And what we're noticing is in the cognitive task, in the cognitive task in the wide stance, everybody pretty much had no reaction time increase. So those of you that had a problem in interference of postural control seem to prioritize the cognitive task and let the postural control task go. And again, we didn't see this. We did not see an increase in reaction time in either stance positions or Stroop task conditions. But we did see the increase in the postural control, and we didn't see deterioration in both tasks, which would sometimes we might expect in any of the stance positions. So I'm just going to go over this quickly. The same with the Romberg. Okay, so for the most part, didn't see a lot of interference. So let's look at what the research is showing on this dual task, using this dual task condition. Are there any questions at this point on the dual task paradigm and how we measure whether a task requires attention? Okay, good. Because this is really important to understanding not only the research that I did, but also understanding the application and why our application for next session, why these ideas are going to help with this knowledge. Okay. So the adults, they found that there's a hierarchy of postural control tasks based on attentional requirements. So sitting requires a lot less attention than standing, or standing with a narrower base of support, to walking, to balance, to changes in the sensory environment. So as our postural control position becomes more challenging, it requires attention. And some of you really experienced that when you were in the Romberg. But it also becomes much more challenging, the whole do task condition, when the attentional load of the cognitive task also affects posture control. So in the easy Stroop task, almost everybody did fine with that, with the postural control and the easy Stroop. But then when I added the difficult Stroop task, that's when people started really seeing interference in postural control, but nobody saw an interference in the cognitive task. At the time of my study, the only work that they did, there was only a few studies with children. And they were in the year 8 to 9 years of age, and they did find interference in postural control with both an easy and a difficult task, cognitive task. So the question I had from the previous research is, from a developmental standpoint, is there a difference in the attentional requirement of postural control in young children compared to older children and adults? Because at the time that I did my study, there was no developmental study looking at children. And when the demands of the postural control task increase, do the young children have a greater interference in postural control compared to older children and adults? And is this interference seen in just the posture control or also the cognitive task or both? So it could be either the posture control or the cognitive task or both. So these are the questions that I posed in my study. So let's just kind of review the developmental trend, because what I'm going to come from this is a hypothesis, what I expected to happen. So in stance, if you look at the postural sway, we know that ages 4 to 6, we have greater variability, greater sway range, and velocity compared to older children and adults. Therefore, the 4 to 6-year-olds are a lot more unstable just in the stance position. So this information has come from other research. But by 7 to 10 years of age, you have less sway compared to younger children, but a greater sway still compared to adults. So even though 7 to 10-year-olds have a less sway than young children, and they are approaching adult-like sway, they still have a greater sway than compared to adults. So it's not yet completely mature. So I want you to remember these age ranges, because these are going to be the age ranges I use in my study and the reason why. So, well, this didn't come out. All right. Yeah, this evidently didn't come out very well on the PDF. So this was going to show some of the sway in measured COP, but we're going to move on because evidently the PDF file didn't show the lines very well. So we're going to move on. So let's look at the developmental trend in the executive attention. So we know that 5 to 10 years of age, the executive function of attention to resolve conflict between two stimuli improves. So that executive function to be able to process two stimuli at the same time improves drastically from between the ages of 5 to 10. But the greatest interval of increase we see is between the ages of 6 to 8 years of age. So what does that mean for children 7 to 10 years? So the capacity is approaching adult levels, and it's still not matured. So if you look at what you would expect, knowing the developmental trends in both of these, what would we predict in the dual task, single task conditions? So in the single task, which is, remember, posture only, you're just standing there, we would predict that in my study that 4 to 6-year-olds would have larger and faster body sway in the wide, and what we use is the modified tandem Romberg. And the modified, I use modified because some of my 4-year-olds couldn't stand heel toe. So I had to move the foot a little bit off, the front foot a little bit to the side, so that they could still have a challenge, but could stand for at least 20 seconds in that position. So that's why we had to use the modified tandem. Okay, so that was one that we predicted. And in the dual task, we would expect the younger children, 4 to 6-year-olds, would have a greater postural control interference in both stance positions compared to older children. Because in my study, I'll be using a very attentionally demanding cognitive task. So it's not going to be an easy task. It's going to be a very attentionally demanding task. So as we if we increase demands of postural control, so the 4 to 6-year-olds would require greater attentional resources for postural control and modified tandem stance. versus wide stance. So we would say that the 46-year-olds would experience even a greater postural control interference in Romberg compared to the wide stance. So those are our predictions. So how did we measure this? So I had 16 children, and here are the age groups, 4 to 6, and you can see why now I divided it into these age groups because of all the developmental trends in these age groups. The posture task was, again, wide stance, which was a lower attentional demanding task, and the difficult task was modified tandem Romberg task. So in the difficult task, I used a visual short-term memory. Now, one of the things that was really lacking in a lot of research in this area of attention and posture control is that the difficulty of the task was not equalized across age groups. So if you compare children to adults, you better equalize the level of difficulty of the task. So this is what we did in my study is I equalized the level of difficulty of the task, and I will talk a little bit more about that in a later slide. Also, this cognitive task, this visual short-term memory task, was also a measure of attentional capacity. What research has shown is that there is a very close link between short-term memory, visual short-term memory, and the attentional capacity of the executive function. So this has been experimentally linked that the bigger the short-term memory, probably the more attentional capacity there is available. So this is the laboratory at the University of Oregon. All subjects had to wear a harness, and for safety reasons. So if the children with cerebral palsy wore one, I had to have the controls also wear one. This is the modified tandem Romberg. She's standing on 2 force plates. We talked about force plates as a measure. This is the visual presentation screen. So this is the screen where I had my cognitive task. And the lights were dimmed except for, so all that was really lit up was the cognitive task. So I wanted to really take out a lot of this extraneous visual input when they were doing the posture control task and the visual presentation task. So here's my task. So the first screen, they just see a plus sign, which means get ready. Then for 300 milliseconds, which is very fast, I show colored squares or colored shapes. Sometimes they were squares, sometimes they were all stars, and sometimes they were hearts. But I only show it for very quickly, 300 milliseconds, because you don't want language to come into it. You don't want them to name it to help them remember. You want it only visual. So it's very quickly. And then I present a mask for about 5 seconds, 5,000 milliseconds. And it's during this period of time that they're remembering the colors and they're standing as still as possible. So this is your dual task. This is when we're measuring posture control right here. And then they're going to quickly answer yes or no. If they're the same, it's yes. It's no if they're different. So I'm going to kind of give you a little bit demonstration here. So you'll concentrate on the task. Let's get ready. And the mask. So it's very quickly, 5 seconds, and then yes if it's the same or no if it's different. And in this case, it's no. So we did not measure reaction time on this. We measured accuracy. So in the posture control only, we did something very similar because we wanted again to measure posture control only in this mask, this 5-second period, which came along at the same time as the other tasks. So we really tried to equalize the task or the postural control task time-wise and measurement-wise to the visual presentation. So we wouldn't confound the results. So postural sway, again, was measured your COP. We looked at sway forward and backward, anterior, posterior. We looked at sway medial and lateral, and we looked at the accuracy. And in this case, it was probability. And the attentional capacity. So attentional capacity and how we equalized is the number of colored shapes remembered at 70% accuracy. So what we did was, before we even did the experiment, we had people sit down in front of the visual presentation, and we presented the visual presentations beginning with maybe 1 or 2 shapes. And if they got 100% on that, remembering the colors on those, then we moved it up to three shapes, and on and on and on until they got 70% accurate. So if we look at, okay, this came out good. If we look at 70% accuracy, we see that the young children could remember about 2 to 3 shapes and colors. Okay, older children about 4 to 5 over in here, and adults pretty much 6 colored shapes that they could remember, and when another one appears they could remember that if it changed colors or not. So there seems to be a really significant difference in their short-term capacity, visual short-term capacity, meaning also attentional capacity. So in our findings, let's look at our findings. So in postural sway, we found that the 4 to 6-year-olds did have the greatest and the fastest body sway in wide and both stance positions compared to the older children and adults. And even the 7 to 12-year-olds had the greater and faster sway in both stance position compared to adults. So attentional resources, so we just saw that. So attentional resources, the least attentional capacity compared to 7 to 12-year-olds and adults. So the 4 to 6-year-olds who only could remember 2 to 3 colored shapes had the least attentional capacity. So let's look what happened in the dual task condition. The 4 to 6-year-olds were the only group who experienced interference in postural control in both stance positions. Okay? And they were the only group that had the greater interference in the forward sway in the Romberg versus wide stance. So they had postural control interference in both stance positions, and it was greater in the Romberg stance. So the Romberg stance was very attentionally demanding for the 4 to 6-year-olds, much more than the wide stance, which is what we would expect. And the no group experienced interference in the cognitive task, including the young children. So it seems like the young children prioritized doing the cognitive task over the postural control task. So good. Now these show up really well. So here's an example. So we have the Romberg right here. Romberg stance, single versus dual task. So here's the single, here's the dual. So this position is forward and back, and this position on the graph is side to side. So we see the wide stance, or the Romberg stance in single for the 4 to 6-year-olds, But look what happens when you add the task. Huge increase in center of pressure in more the forward, backward position. Okay? But if you go to the 7 to 12-year-olds, okay, look at Romberg compared to even the 4 to 6-year-olds. They're a lot more stable just in the posture only or single task. And you add the dual task, and they had an increase, but it wasn't significant enough to count it as an increase in the research. But you can see that there are many of the children experience some increase in the Romberg. And in the adults, look at this. Pretty much what you guys, a lot of you experienced, is you really, even with an intentionally demanding cognitive task, which was the Stroop test 2, you were able to maintain the Romberg position without interference. And that's what we saw from most of you also. So let's put this in kind of functional terms and what we might see in the schools. And then we're going to go to questions. So what we see is that the cognitive task appears to take priority for attentional resources in dual task conditions. So what we saw there, what does that mean that we might see in a school environment? So what do we see with children? Children sitting for long periods of time, they have to frequently change postures and sitting because they fatigue, and that may require more attention because they're trying to get in a position that has less demands on their posture so that they can pay attention to what's happening up in front with the teacher. And what do we see children do to compensate to stabilize their posture in order to attend to the cognitive task? We see a lot of them wrapping their feet around the chair to help support. We see laying head on desk to write, supporting weight on the arms, kneeling in a chair to give them that extra support. I had one teacher talk to me about a child that was so focused on his reading that he fell out of the chair. And since then, I've heard that this is not totally unusual. So it's pretty amazing. The clumsy child falling on the playground. He's not, if he's paying more attention to what's going on at the playground, he's not visually attending to what's going on right at his feet, crossing obstacles. He'll trip right over something on the playground. We may see increased falls in busy hallways. One thing about handwriting, and I've talked to several OTs, is what they see is reverting to lower level automatic postures for writing, like grasp. Maybe they'll change their grasp just so that they can form their letters, concentrate on forming letters, and not concentrate on their grasp. So a child that's trying to learn both things will revert back maybe to the easier automatic postures. Sometimes we'll see that in children that are learning to crawl. They may want to get somewhere to process, maybe they're processing information or an event, and they get back down on their belly and not on their hands and knees. So those are some of the things that we may be seeing because they're sacrificing their posture for processing what's going on around them in the environment. Okay, at this point, before we go on to children with disabilities, are there any questions or comments that you want to make? Maybe you've seen in your own class or questions you have on the study, this is the time to ask those questions. Wow, you guys understand this? This is great. This will make this will make application so much easier. Good. So I'm hoping now you're starting to see that some of the behaviors that you see in school may be due to a multitask situation. Okay. So we just talked about attention and posture control from a developmental standpoint, looking at it and how that develops. Now let's go on to what about children that have disabilities then in both posture control and attention. What happens to the attentional requirements then with posture control? So I studied children with cerebral palsy because I happened to be on a grant for looking at children with cerebral palsy. So if we look at the definition, it's a neurodevelopmental impairment caused by and I want to emphasize non-progressive lesion. So even though the lesion may be non-progressive, we may see progression in other systems because of the lesion. So because of this lesion, we often will have deficits in motor, sensory, and cognitive systems. And the etiology is physical damage to brain tissue from blood or lack of oxygen, and this can occur before, during, or after birth. So we classify cerebral palsy into different types depending on specific brain regions or areas of the body that are involved. So in my study, what's in red is the children with cerebral palsy, the types that I used in my study. So we have children that are classified as spastic CP, which then they have more a motor cortex lesion, or ataxic CP, which they have lesions in the cerebellum with jerky movements and poor balance and lack of adaptation. And then for children with spastic CP, I've used the children that have diplegia CP, and that means two limbs. And in this case, lower extremities are involved. So more involvement in the lower extremities than the upper extremities. And these are the two types that are often used in research with children with cerebral palsy. So again, we look at postural control system. We're going to look at what happens to postural control when these children have deficits in a lot of these areas. And again, what's going on with the attentional requirement. And I'm going to also add the respiratory function because that is also important when we talk about children with cerebral palsy because of the low trunk tone. It becomes another system that really affects postural control. So let's start with the musculoskeletal. So a lot of our children will have, because of spasticity, will have change in the makeup of the muscle. It's not as elastic, and we have a lot of weakness because it's not operating the same way as a normal muscle does. We have limited range of motion at the hip, knee, and or ankle due to abnormal movement patterns or lack of moving joints through the full range. So a child that is growing normally, typically, will move through a full range of movements as they crawl and sit and stand, and pull to stand, moving in and out of position. And so their muscles grow with their bones very easily. But a child with cerebral palsy who has minimal repertoire of movements The bones don't grow, or the muscles don't um, extend as well as the along with the musculoskeletal growth. So you see limited range of motion. And then this little gal is standing in what we call a crouch position, and you see it many times. You get an increased flexion at the hips, an increased flexion at the knee. And what happens is you have that line of gravity. Remember in our alignment how important it was to stand in that line of gravity and to reduce the musculature, the muscle power that's needed to stand within the line of gravity. Well, look at where her hips are behind the line of gravity. Her knee, the line of gravity is behind the knee, so it increases the flexion. And some of you did stand with slightly bent knee and did respond that, yeah, you felt that the muscles were working a lot harder when you were in this crouched position. So postural tone is constantly at work because of the range of motion. So that really does have an effect on postural control. So let's look at body schema. Now you remember in head control in the child, by 10 weeks of age, we start to get organized muscle control in head control. So if the head goes forward, the back neck muscles come in, and the head falls back, the forward neck muscles come in to pull it forward. So you get this organized synergy of movement. So Ellenberg did a study and said that there is a delay in if there is a delay in head control by 4 months, which is 16 months beyond the 10 weeks, or 16 weeks beyond the 10 weeks, uh, it's an indication of cerebral palsy. So that's how important head control is in the beginning of forming that body schema. Bernard noted that the abnormal head orientation and whole body movements may affect the development of an efficient body schema. So it seems like the head control in the very beginning of cerebral palsy, as they go up against gravity, is a real indication of what's going to happen to that body schema. Experienced sitters, so we flow down. What happens at head control seems to happen at sitting. So remember in experienced sitting that eventually at 8 months of age, children are able to control sitting from their hips first and then up. So that freed their head and arms up to explore their environment. So that you could get a lot of adjustment at the hips and pelvis and not at the head and the arms and the upper trunk. But in children with cerebral palsy, it's a top-down muscle activation pattern. So they begin with their head and their arms to keep their balance. Well, that doesn't work very well if you're also trying to explore the environment. So again, it's coming from the head first and not the hips. And also what they found is there is no organization of forward and backward muscles. So if they move backward, all the muscles stiffen. If they move forward, all the muscles stiffen. So the stiffening effect keeps them from falling over, but it's not very flexible. That allows them to explore their environment in different ways. And again, like we said, there's no spatial temporal organization of muscle responses to loss of stability. So that spatial temporal is just what we saw in talking about bottom up and backwards or forward movement. So let's look at this. This is on the left here. We have normal sitting. So if you see this line of gravity comes right through the joints of movement, and so the muscle activation is very postural control or postural muscle tone doesn't have to be very strong to keep in this position because she is aligned within gravity. But what happens to the child? Let's say this child has tight hip flexors, so he can't sit directly up over his hip, so he's slightly extended in his hips, so he has to compensate by coming forward with his head and body. So that keeps his muscles, it increases his muscle effort and his trunk muscles. So he's constantly sitting with those muscles working very hard to keep him upright. Not a very stable position, and it could be tiring very easily. So let's look at the stance position. What happens in stance in children with cerebral palsy? So children with spastic CP, they recruit proximal to distal and hip to ankle instead of ankle to hip. So again, kind of like sitting, they go from the hip down to the ankle instead of from the ankle to the hip like we normally do when we stand. And again, we have that co-activation. Muscles stiffen the leg to prevent movement at a joint, so they don't have that nice sway synergy that allows them to be more flexible in their postural control. Children with ataxic CP, they have a typical spatial temporal organization. So they have that organization beginning with the ankle and moving up to the hip when they sway. But they have a deficit in scaling or adjusting the force of the perturbation. In other words, what happens is they may sway one way, but the force to right themselves back into the line of gravity is too great, and so they sway backwards. And then they have to again readjust, and it may be too great, and then they sway forward again. So it becomes a oscillating movement to regain balance or to maintain balance. So you see them swaying, huge sway back and forth. Very unstable. So we're going to look at sensory strategies. So what they have found is that children with CP have deficits in sensory conditions or strategies. So they've tested children with hemiplegic spastic CP, which means only involvement on one side. And they can wait somatosensory when the vision is present. So I want you to remember, these are older children, not 4 to 6-year-olds. These are 7 to 12-year-olds. So they can wait somatosensory like an adult can when the vision is present or completely absent, but they're destabilized when the vision is inaccurate. In other words, the room is swaying, but they're not, but they read it as it is swaying. So they respond to that. They cannot recognize inaccurate vision in this case. And the ataxic CP has difficulty relating to any appropriate system with any changing conditions. So remember, the ataxic CP is due to cerebellar damage, which is one of the functions of cerebellum is in posture control is to help the body or the sway adapt to changing sensory conditions. So we would expect a child with ataxic CP with problems with cerebellum to not be able to adapt to changing sensory conditions. So I'm going to show you a video of a 4-year. Now remember this, I want you to remember that this age of this little gal with CP is 4 years of age, and think about what's going on at 4 years of age developmentally. She's right hemiplegia CP. She has no problems with range of motion. She wears an ankle foot orthosis and has a lift due to leg length discrepancy on the right. So she's a right hemiplegic. But she has very, very poor attention. So her executive functional capacity is very low when it comes to resolving conflict between two stimuli, or she's very impulsive. Okay, so let's, Ben, we're going to have you do video 1. Okay, here we go. So this is her standing on foam. So we're taking away her somatosensory system, but she can really use her vision. You see a little bit of sway. I want you to compare her now to that little boy we saw in session 1 who's exactly the same age. So she does pretty good. She has some sway there. Remember, we're on foam. So, okay, so now no vision and a hard surface. So we're going to look at, if we take away vision, not too bad. No vision and foam. So we're going to really take away somatosensory and vision. So look at her posture. Whoa. This is a good one. This one right here really demonstrates. Whoa. Okay. So this little one, remember, she's 4. You take away that vision, and she really has some difficulty, and you see those postures that she gets into to regain balance. Okay, so that's a really good demonstration of the use of sensory strategies in the child with hemiplegia CP. Vision seems to be very important for this child. Okay, let's go on to the next. Okay, what happened? What does the executive attention look like in cerebral palsy? What happens there? So in children with CP, they found that there's lesions to the pathways that are connecting the prefrontal lobe to the other brain regions. And the prefrontal lobe of your brain, which is kind of located around your forehead area, is where they think the global workspace is. So can you see the tremendous deficit that you would get in executive attention if you have interruption in conscious processing in that prefrontal cortex, because some of the circuits aren't getting in there. So what they're finding is they have deficits in control, in inhibitory control, and resolving conflict between two stimuli, which we really saw in this little gal with hemiplegic CP. And children with ataxic CP have shown that with damage to a certain area of the posterior cerebellum, that there's difficulty in shifting attention, scanning, or shifting between two stimuli. So sometimes the way we deal with two stimuli is to shift between one or the other. Well, a child with ataxic CP may have difficulty with this in doing two tasks at the same time. So our inquiry for our research is, what is the attention requirement for postural control in normal stance for children with CP with deficits in both postural control and attentional systems? And does the attentional requirement increase when postural control is more demanding in narrow stance? So let's go to the hypothesis. So we just looked at all the problems that these children have in these areas. So like we would hypothesize or predict that, like the typically developing young children, children with CP would undergo postural control interference in both wide and narrow stance positions, with the greatest interference occurring in narrow stance. So if young children did with their postural control, we would for sure expect children with CP to experience that. So here's my methodology. It's very similar to the first study, except I use narrow stance as the difficult task as opposed to modified Romberg. And the reason behind that is some of my children with cerebral palsy could not even stand in the modified Romberg position. So we had to use narrow stance. Cognitive task, again, was very similar to the one in the first study. So here's a number of shapes. So children with cerebral palsy at 70% accuracy really could only remember about 1 to 2 shapes. So that was their maximum. So that's a lot less than young children even. So they were really significantly less in attentional capacity compared to their peers. So as you remember, going back, let's go back to this slide, that the children that I used were 10 to 14. So I used the older age group because I didn't want to confound the developmental issue of this study, looking at children with cerebral palsy. So even at 10 to 14, they can all remember 1 to 2 shapes. So really a lot of deficits in that attentional capacity. So let's look at single versus dual task in the more difficult or challenging posture control. So if you look at the ataxics in the dual task from the single task, they had the greatest deficit in medial lateral, meaning side-to-side movements. CP did too, compared to even the 4 to 6-year-olds or the 7 to 12. 7 to 12 did pretty well in narrow stance, and even in the dual task condition. So our summary of findings is that 4 to 6-year-olds had the greatest postural sway in wide stance compared to children with CP and older children. Now that was surprising. We thought even in wide stance that the CPs would sway greater, but what we found is that the younger children still had the greatest postural sway. And we're going to find out why that is. Children with the CP, especially children with ataxia, had the greater sway in narrow stance. So even though CP could maintain a pretty good postural control in wide stance, the minute we challenged that posture in the narrower stance, their sway increased drastically, and more so than what we saw in the young children. So what happened in the dual task condition? So children with CP, like the 4 to 6-year-olds, had postural control interference in both stance positions. So even though the older children with CP had pretty good stance position in posture only control, the minute you added a dual task, or the minute you added that attentionally demanding task, they had stance, postural control interference in wide stance as well as narrow stance, but especially in wide stance, whereas their age peers, their age-matched peers did not. And the children with ataxia CP also, and remember, if you remember what's going on with ataxia, they're oscillating. Remember, they're oscillating back and forth, so they're very unstable, both in the wide stance and not so much the wide stance, but especially in the narrow stance. So they're the most unstable in the narrow stance. So not only did they have postural control interference, but they were also 2.4 times more likely to have correct answer in the wide versus narrow stance. So they had some errors, more errors in their narrow stance in the performance of the cognitive task. So that was the only time that we really saw interference in a cognitive task, was in the children with ataxia CP. So what does this mean on behaviors we may observe in classrooms? So children with mild to moderate CP may appear to be similar in postural control as peers until a dual task condition. So they say, wow, they're doing really well. Then you add a difficult task and you may see something else. Priority attentional resources in dual task condition appears to be the cognitive task, unless the condition causes posture instability. Then both tasks may have interference in performance. So I had one little guy that was standing on this platform, and he did pretty well even in some in a previous research. He did pretty well in regaining balance. But the minute I added, just even standing, the minute I added this difficult posture, he immediately had to take a step and almost fell. So it was very hard for him to do both of these tasks. And what we may see is that children with CP may be more dependent upon external supports in busy environments. So I had a little gal with ataxia that the minute we got out into the hallways, she just grabbed my hand. And the minute I gave her a little support, she just really leaned into me. And why? Because she wanted to see and process all of what's going on around her. Again, we may see them revert to lower automatic postures in order to perform a cognitive task. Or we may see a decrease in performance in cognitive tasks. So we may just see a really long delayed response or decreased accuracy. And I'll give you an example of what happened, what I observed in a circle time. It was a circle time, and the therapists were working with the little guy at the same time that he was participating in circle, and they were putting him into a very attentionally demanding posture to work on balance, but at the same time, the teacher was really trying to get answers from people in the kids in the circle when she was asking questions. So when it was his turn to answer the question, and he was in this attentionally demanding posture, he did not answer right away. I mean, it was really delayed. In fact, he didn't answer at all, and yet you could tell that he was trying. But what happened is the teacher thought this might be a behavior, that he was just keeping the answer to himself and just needing to get attention from everybody and not answering. So you got to be really careful when you evaluate behaviors, that you really consider what kind of posture, what's going on, and the demands of the posture and the demands of the task that you're asking. So in this case, it most likely wasn't his little behavior. It was the fact that he was in an intentionally demanding posture. So the other thing we see in busy environments is risk of falls. So what we may not see falls in the classroom because they're used to the classroom, but in a busy environment where things are moving quickly and there's novelty, you may see more falls. So this is an example of the demands that learning of posture control have on attention. So this is a 5-year-old diagnosed with cerebral palsy, but more hypotonic. This is a video from a clinic, and she's learning to stand. So previously she's used crutches, and now she's learning to stand independently. Her executive function is affected. She's distracted by visual and auditory stimuli. So she has difficulty inhibiting irrelevant visual and auditory stimuli. So let's bring up that video and take a look at her. So whenever you are learning something new, that's going to be attentionally demanding. It's not automatic. So this is standing posture only. So, and take a look at her body schema. What does she use to maintain her posture? A lot of upper extremities. Yep. So that's her body scheme. Okay. I just want you to observe at this point. Okay, now I'm going to add a dual task. So she could not do the computer task, so I had her do real objects. So she was to name if that object was the same or different. So she does pretty good when I present the objects quickly. And only one object, that's all that she could really remember. So she does pretty good with that one. Now I'm going to increase the time that the information needs to be stored in short-term memory, which means that I'm complicating the cognitive task. So there is a delay in response. Now let's see what happens to posture control. Look at her crouching. She's crouching more. Okay, and there's a fall. She's thinking. Oh, okay, so see, we complicated the task by having her store it in short-term memory longer. And when she does that, it's more difficult, and you get postural control interference. So, okay, let's move on. So, the only studies, when I did my study, the only studies that really looked at attention and individuals with deficits in balance were studies looking at balance impaired older adults, mainly because they were looking at what causes older adults to fall. And the reason why they got so many grants in this area was because of all the broken hips that were occurring with older adults falling. So a lot of grants were available to look at why postural control decreases in older adults. So there was nothing looking at children with deficits in postural control and attention. But let's see what they found in balance impaired older adults and see if we can apply it a little bit to some of our kiddos. So they found that in certain sensory conditions that more attention was needed to regain balance, and even in a very simple auditory reaction time task. So it looks like for balance impaired older adults, adapting to a changing environment takes a lot of attention. It takes a lot of attention to recover balance. So when they were doing a dual task, doing a cognitive task at the same time they were regaining balance, it took a lot longer to stabilize themselves. And we saw a little bit of that in the previous video. And an interesting study was done in a nursing home, and they found that people that had risk of falling or were really balance impaired had to absolutely stop walking when they were talking. They couldn't do both. So I've seen that many a time in the classroom, not only the classroom, but walking out to recess. I was working with a little boy with hemiplegic CP, and he was learning to use a quad cane, and they wanted him to be integrated at recess. But by the time that he started walking, everybody was already out at recess, and he wanted to talk. He wanted to talk to somebody because he couldn't talk in the classroom, and he's very, very social, cute little guy. But trying to get him out to the recess, he wanted to talk, but every time he talked, he stopped. So by the time that he and I got out to recess, it was 3/4 of the way over. So there's a lot. We're going to talk next week or week after Thanksgiving in the last session about some of the options that we consider when children that have postural control to reduce that attention. So we're going to get into that the next session. So what do we see in some of our CP kids, like this little guy? So this is a cute little guy. I really enjoyed him. He's very smart. 7-year-old, and he has spastic cerebral palsy, limited range in knees, and his attention though was very good. He could really focus on a task for a long period of time. So let's look at video 3. We're going to look at him walking and talking and see what happens. So this is him walking, and he's quiet. There's no talking. So he does pretty well. So again, he can manage in a hallway. Of course, it's not busy. He has pretty good head control. He's really concentrating on keeping those knees straight. So he does pretty well with his walker. So let's look at walking, telling a story. So this is a familiar story. So you're going to hear a little bit in the background. He can walk and tell a familiar story really well. He does well with that. And this is walking and carrying on a conversation, which is a little bit more difficult. So his therapist is walking with him. So he has to stop. Now I want you to watch the knees. Look at that. His knees are starting to collapse a little bit. He can walk a little bit, but when he carries on a conversation and he's concentrating on the conversation, he's got to stop. So we're seeing some of that same thing that balance impaired older adults we're seeing and also in our children with cerebral palsy. Carrying on a conversation is very attentionally demanding. And this is with a child who has very good attentional capacity. So I want to just mention a little bit. We talked about respiratory and postural muscles. So what we're finding is some of these children that have very poor breathing patterns and very poor trunk control actually have to concentrate on breathing when they're also sitting. So what research has shown is that every muscle of the trunk is both a respiratory and a postural control muscle. So when you have to use both, you're really in a dual task condition. If breathing is compromised, postural muscle activation is reduced to focus on immediate needs of respiration. So the postural control in sitting is going to be reduced just so the child can breathe. So that is sometimes why talking is so difficult when they're doing both. So a lot of times it leads to postural adaptation. And as we saw with that little guy in the hallway, he had to give up extending those knees because he had to attend to the conversation. And in normal adults, articulation increases postural sway. That was shown by Yardley. So just the fact that we articulate, or while we're standing and we're talking, it increases our sway. So conversation and breathing in conversation is really a multitask condition. So now we're going to look at just attention and balance recovery. So we're going to look a little bit at this same little gal that we saw at the beginning who is learning to stand, we're going to look at what happens to the cognitive task when she loses her balance. So we saw in balance impaired older adults that when they are in positions where they're going to lose their balance, they give up on that. The cognitive task does not get prioritized anymore, but the postural control task does. So let's look at what happens to this little gal. Okay, this is the more difficult task of waiting. Okay, she loses her balance. Now let's see if she can remember. So she's not even, she's trying to remember. And this was the only time that I saw in testing her that she actually had no answer. Because when she was trying to regain her balance, she lost what was stored in short-term memory. So when a child tries to regain balance, or is continually to regain balance, they may actually completely lose that cognitive task or the ability to even respond to that cognitive task. Okay, so I think we're ready for questions or discussion. Um, but I hope those videos demonstrated to you the attentional requirements um, for children with deficits in both systems. You really, I think the most important thing that I've gleaned from looking at that, and I've had to really do it myself and be conscious of it, is allowing for processing time. I think many times we are quick to rush in to help them or to do it ourselves and not allow them the time to process an effortful task, especially if they're also working on breathing or positioning or posture control. So you really have to understand what's going on um, with the child in all systems. And again, that's from the dynamical systems framework. So do we have, let's see, we have one question here. Okay, my CP study. Well, unfortunately, that's it's I have the attentional study in your handouts. The PT study, um, just if you guys want to email me, I will email you guys the CP study. I can't give it to you out in a PowerPoint presentation on the web because that's copyright. But um, is there a way, Carrie, that I can get my email out to people that want the um, study? Yes? Okay. And Carrie's going to do that. So for those of you that want to have a copy of the CP study, I will just, Carrie's going to give you her my email, and I will email you that study. Okay, so any comments? Okay, so next session. Okay, Carrie's putting down my email. So the next session, we're really, the next session is going to be about how I've applied this information. So when I got back from Oregon and doing my study, I started to really start applying this information to what I was observing and to some of the remediations and when I was working with children. So the application is what I've observed in classrooms and what I've tried. So I hope that will be helpful, and you guys can then continue on with that. Um, so I've got one. Question here. Are kids with orthotic supports more stable in their balance, giving more leeway to attention? That's a very good question because it depends on the AFO. A study has shown that if you have an AFO that's very stiff and it doesn't move at the ankle, it's non-dynamic, is that the muscles do not work very well underneath that AFO. In other words, they put these AFOs on typically developing children and found the same thing. So when they were on typically developing children, the children couldn't respond to postural problems the way that they normally, to postural perturbations or imbalance the way they normally respond. And I would guess that that might actually increase attention. So you have to look, I think you have to really look at, is it giving a lot of support or is it interfering with the ability to be more flexible and regaining balance and posture? So you have to kind of weigh what's going on. That was a good, very good question. So another question is shoe inserts and DAFOs, dynamic AFOs, can provide sensory feedback. Right. So if you have a more dynamic AFO, you're getting much more sensory feedback because you've got movement at the ankle. So that's a very good point. So these are good questions. I hope this gives you some